But the imaginary part, that is particular integral, is different for all the types. We will see for type 1. So the type 1 is of the form x equal to e raised to ax. When this x is e raised to ax, then our particular integral yp is given by 1 upon fd into x. In this case, our x is e raised to ax. Particular integral is given by 1 upon fd into x. The type 1 is x equal to e raised to ax. So this is our solution. But in this is the function of d, that is, it is a polynomial in d. So it will have terms d square plus d cube plus d raised to 4 and so on. So what we are going to do in yp, we are going to substitute d equal to a, where a is this constant. So this will become e raised to ax upon f of a. When we replace d by a, it will become the polynomial in a. Okay, so this will be the solution for yp. So as you can see, our yp is nothing but d equal to a 1 upon f of a into e raised to x. In this case, f of a should not be equal to 0. When our f of a is equal to 0, we have to separate the roots which are non-zero and which are 0. So non-zero roots we will write as phi of a, and 0 roots we will write as d minus a the whole raised to r. Okay, some students might get confused. So this solution of particular integral is valid only when f of a is not equal to 0. When f of a is equal to 0, then we have two parts, that is non-zero parts and 0 part. Non-zero part we are going to represent as phi of a, and 0 part we will represent as d minus a into r. Then our yp is given by 1 upon phi of a into d minus a the whole raised to r e raised to ax. Since this is a non-zero part, so we can replace d by a, so this term will remain as it is. Since this part is creating problem, because if we substitute a in this equation, so a minus a will be 0 and it will be 1 upon 0 will be infinity, so our yp will be infinity. So to avoid this, whenever we have 1 upon d minus a the whole raised to r, where a is e raised to ax, okay, then the solution for only this part is given by x raised to r. R is the power of d minus a upon r factorial. Okay, so remember the particular integral for type 1, that is x equal to e raised to ax, is given by this, where in our fd we replace d by a, where we have to see whether our f of a is equal to 0 or not. When it is not equal to 0, this solution is valid. When it is equal to 0, we separate f of a into two parts, that is non-zero part and 0 part. So in this part, in non-zero part, we will put d equal to a, so it will become phi of a. So here we have represented phi of a. And in this part we cannot substitute d equal to a, because when we substitute d equal to a, it will be a minus a the whole raised to r, which will be 0. So 1 upon 0 will be infinity, then our yp will be not valid. So the solution for 1 upon d minus a the whole raised to r is nothing but x raised to r upon r factorial in type 1. So remember this concept will be more clear when we see the problem on this type. So problem on this type we will see in our next video. So stay tuned for our future lectures.